In this section, we translate Azure-managed and dedicated HSM capabilities into the language of auditors, regulators, and security frameworks. You'll see how HSM-backed encryption, access control, monitoring, and key governance support evidence requirements in GDPR, HIPAA, PCI DSS, ISO 27001, NIST CSF, SOC2, and the EU AI Act. Up to now, you've focused on how Azure HSMs work, how to deploy them securely, and how to operate them in real environments. Now we shift perspective. We'll turn that technical mastery into compliance language, so you can demonstrate control coverage to auditors and align what you've built with major frameworks. Think of the HSM as a powerful engine, not the finished car. It gives you strong encryption, protected keys, better separation of duties, and solid audit trails. But frameworks don't certify engines, they look for complete controls. That means defined ownership, clear policies, monitoring and reviews, plus evidence that these controls run consistently. Keep asking, which specific requirement does this HSM-backed control help me prove, and how will I show it? Across most compliance frameworks, Azure HSM contributes to 4 recurring control themes. First, confidentiality. HSMs protect the encryption keys that guard sensitive data, regulated records, payment and health data, and AI models. Second, integrity. Using those keys for signing and encryption helps prevent unauthorized changes to data, logs, and transactions. Third, accountability. RBAC, detailed logs, monitoring, and access reviews create traceability. Finally, resilience, backups, soft delete, purge protection, and runbooks reduce the risk of permanent key loss and disruption. GDPR is all about limiting what can go wrong with personal data. Azure HSMs help by tightly controlling the keys that encrypt that data. Once data is encrypted or tokenized, direct identifiers can be separated, enabling pseudonymization patterns. Because those keys live in a hardened boundary, access can be restricted and audited. If a breach occurs, attackers may see ciphertext, but without HSM-protected keys, the data remains unintelligible, reinforcing data protection by design and by default. GDPR doesn't just ask whether you use an HSM, it asks whether you can prove how you control it. Technical evidence comes from configuration baselines, key inventories, access assignments, and network restrictions, plus audit logs that show who did what, when, and whether access was denied. Organizational evidence is the story around those controls. Approvals, runbooks, key rotation procedures, incident response plans, and how all of this links into risk assessments and DPIAs. HIPAA's security rule focuses on how we protect electronic PHI, and Azure HSMs map neatly to its technical safeguards. Access controls define who can manage keys and who can actually use them. Audit logs show every key administration and use event, supporting investigations. Integrity controls rely on cryptographic checks to detect tampering. And transmission security uses HSM-protected keys for TLS, app-level encryption, and secure data exchange across your healthcare systems. HIPAA expects you to treat encryption as one part of a larger operating system. Start by classifying where ePHI lives and which workloads touch it. Then design your encryption strategy and HSM usage around that map. Assign tightly scoped roles so admins, security teams, and app identities each have only what they need. Enable detailed logging of key usage and privileged actions. Finally, review those logs, test incident response, and fold all of this into your ongoing HIPAA risk management program. NIST CSF 2.0 gives us a language to show where Azure HSMs add the most value. In Govern, HSMs formalize key ownership, roles, and responsibilities, so risk and compliance are clearly assigned and auditable. In Identify, they anchor accurate key inventories, application dependencies, and data classifications. In Protect, they enforce strong access control, hardware-backed cryptography, and lifecycle controls. These capabilities then plug into your broader enterprise risk and security architecture. Azure HSMs aren't just about protecting keys. They play an active role in your detect, respond, recover pipeline. Detection starts with rich logs. Every key access, admin change, failure, or anomaly feeds tools like Azure Monitor, Log Analytics, and Sentinel. Those same logs drive incident response, helping analysts confirm or rule out key compromise. Recovery then relies on tested key backups, documented dependencies, and rehearsed restoration so critical services survive key loss or unavailability. ISO 27001 and SOC 2 ask similar questions. Are your keys protected? Who can access them? How are changes controlled? And can you prove what happened? Azure HSMs help you answer those questions. They enforce strong cryptographic controls, integrate with Azure RBAC and privileged access workflows, and produce detailed logs for key events and admin actions. Those capabilities align directly with policies, risk treatment plans, and ownership structures in your broader assurance program. PCI DSS cares less about which product you use and more about how you manage payment keys across their entire lifecycle. Azure HSM helps you centralize that lifecycle. Keys are generated securely, distributed in a controlled way, rotated regularly, and eventually retired and destroyed. Access is split between application teams, key custodians, and security admins, enforcing separation of duties. Detailed logs and monitoring then give you the evidence you need for audits and incident investigations. The EU AI Act doesn't just care about models, it cares about every regulated asset around them. HSM-backed key management gives you one trust anchor for the whole lifecycle. Training and inference data are encrypted with keys you can prove are controlled. Model artifacts, feature stores, and pipelines are locked down with strong access control. And signed logs and provenance records provide integrity, so you can demonstrate who did what, when, and with which model version. A cross-framework control matrix lets you design once and comply many times. Start from shared objectives like encryption, key lifecycle, access, monitoring, incident response, and recovery. For each, document which Azure HSM features you use, who owns the process, what evidence is produced, and how often it's reviewed. Then map that same row to GDPR, HIPAA, NIST CSF, ISO 27001, PCI DSS, SOC 2, and the EU AI Act, and reuse it for audits and reviews. You've now seen how Azure HSM capabilities map to real control outcomes: encryption, key protection, access control, logging, and resilience. You've also connected those outcomes to major frameworks using consistent security language. In the next section, we'll turn these mappings into audit-ready architectures, evidence packages, and risk review narratives.